Okay, so now we have the player who is happily jumping on the platform. What we need to do is we need to randomize the platform's movement, or actually move the platform. Well, for that we are going to go under Assets, Scripts, and here I'm going to right click and create a new folder. This is going to be our platform scripts, and inside of it we are going to right click, create a new C# script. Not JavaScript, man, not JavaScript, it's a C# script. So C# script, which I'm gonna name platform. And I'm gonna hit enter, and let me just remove this from here. And what we need to do is we are gonna first attach it on the platform, which is this one right here. So the above one, not the down one, this one we don't want to touch. And double click it, and here we are. So I'm quickly just gonna tag it here. So I'm gonna tag it here, class. And if you are wondering why am I tagging it always here at the bottom, I'm seeing here, class. Well, sometimes you lose yourself in your code and you forget to close somewhere a curly bracket, or you have a problem where you need to reformat your code and you don't see all curly brackets. Well, this one will help me know where is the end of the class, because usually that's the problem you have. For example, a curly bracket here, and then something like this happens. So then you will know which one is the class's curly bracket, so that you can delete the extra one that you don't need. So what we need to do is if I go back here, the first thing I am gonna take here this platform. And for example, if I go up to here, notice here the bounce. So notice the bounce. So if I go up to here for something like that, 1.5, let's say, so 1.5, this is negative 1.5, and this is 1.5. Let's say if we can go 1.55, 1.6, yes, we can go 1.6. Now, this will be the bounce for, well, our platform, where it can go, the maximum where it can go left and maximum where it can go right. Again, I've just gone here and you see it's 1.6. So if I go now in MonoDevelop, what I'm gonna do is I'm gonna say private float bound left is equal to negative 1.6f, and I'm gonna say comma bound right is equal to 1.6f. As I said, I just went here in my program, and notice here I've just taken a look at the x position, which is 1.6. This is in unity meters, and if I go here it's negative 1.6. If I just remove the decimal points, so 1.6, and this will make our platform go up to here and no more, no further. Now, as I said, this right here that you saw, 1.6, is in unity meters, so that will represent the bounds of our camera. So private float, bound left and bound right. And if you're wondering what I did here, this is a shorthand of writing like this. So instead of typing this, and I go here and say private float, bound right is equal to 1.6f, I simply go here and I say comma and I say bound right, which is equivalent to this right here that we just did. And we also need a speed variable. So I'm going to say here private float speed is equal to 1f. And we need a variable that will indicate whether we are moving left or right. So I'm going to say here private bool left is equal to false. Or we can simply put it like this. So private bool left. Okay, now what do we want to do? Well, at first I'm going to change the start to awake. And when we start the game, we want to randomize the movement. So we want to randomize, we don't want to make all of our platforms, for example, move from the left side and they start moving on the left and every single platform starts moving on the left side. Well, we don't want that. And here I added extra. What's the name of this? I forgot. Anyway, colon. Hey, I remember. So it's colon. Anyway, as I said, we don't want to make all of our platforms move from the left side because that will mess up our game pretty bad. So instead, I'm going to go here, I'm going to say private, and I'm going to say private void randomize. So I'm going to say randomize movement. So movement like this. And here what we are going to do is we're simply going to say if our random.range from, let's say, 0 up to 2 is equal to 0. So if the random range from 0 up to 2 is equal to 0, and if you know random range, it will give a random between these two numbers, not including this number right here. So it will give either 0 or 1. So it will not include this number right here that we input. If we input, for example, 3, it will not include 3. So it will give a random number between 0, 1, and 2. But here we are going to put 2 because we want a random either 0 or 2. So if the random is 0, what we're going to do is we're going to say left. So left is equal to true. We're going to start moving from the left side, else left is equal to false. Then we're going to start moving from the right side. So going here in the awake function, we are going to call our randomize movement so that when we spawn our platforms, we are going to, well, first randomize their movement. Are we going to move them left or are we going to move them right? So what we want to do now is we are going to go back here and we are going to create a private void move left. This is going to move our platform to the left side. This is going to move it to the right side. So this is a function. And what we're going to do here, we're going to test if move left. So move, or if left, excuse me. So if left is true, meaning that we need to move left. Or we can simply type here move. And we can erase this right here. And we can say here else. So else. Now, if we are supposed to move left, what we want to do is we're going to say vector3 temp, which is the temp variable of our transform.position. And we're going to say temp.x, which is the x position of our platform, minus equals, which means we are going to the left side because the negative side is the left side. So minus equals our speed multiplied by time.delta time. And delta time is the difference between every frame. So the update is called once per frame. The difference, the time difference, which is a really small number, is delta time. So the difference from one frame to another frame in terms of time is this delta time. So we are going to multiply the speed by the delta time, and we are simply going to say transform that position is equal to temp. And we are going to test here if our transform, so transform that position that x is less than our bounds left. So bounds left or bound left. So bound left, I typed bound left instead of bounds left. But anyway, if our bound left, so if our current position is less than the bounds, so we set the bound left to be where? Negative, so negative 1.6 minus 1.6. Now, if our current position is less than this number, we need to change direction and start moving to the right side. The same way, if we hit here 1.6, then we need to start moving to the left side and, well, so on and so forth like that in circle. So if our current position is less than the bounds on the left side, we're going to say left is equal to false, meaning then we are going to start moving on the right side. And else here, meaning if we are not moving left, then we are going to move right. We're going to do the same thing here. So copy the whole code, except here what we're going to do, we're going to say plus equals because we're going to the right side. Right side is the positive side. So our temp x, which is the current x position, will be plus equals, so we are going to add to it time multiplied by delta time, and here we're going to say if our transform position x is greater, so if it's greater, not question mark, if it's greater than the bound right. So if it's greater than the bound right, our turn left will be true, then we are going to start moving to the left side. And let me just go here, in the update we are going to say move. Like in the song, move, beep, get out the way. So I'm not going to say that because this is, well, not a place and time for that. This is education, man. Don't think of me like that. So as I said, if our transform position, meaning the current, our x position, so the current position where the platform is, if it's greater than the bound on the right side, meaning I just explained it. So if we go here and notice, if we go up to 1.6 and if we go just 1.625, that's greater than 1.6, we are going to start moving to the left side. And the same way, if we go below negative 1.6, then we are going to start moving to the, well, right side. And we can test it out right away because we have attached our platform. And notice now, if I, well, run the game, notice how our platform now goes up to here and then starts moving backwards. Again, go up to here and go to the left side. From the left side, go up to here, then to the right side, so on and so forth. That is because we have tested it right here, man, because that's why we took the bounds left and the bound right, which is, well, somewhere around here and somewhere around here. Of course, you can play with the numbers, maybe make the platform move a little bit, I don't know, a little bit more on the left and on the right, but this is working for us. Now, one problem we will have here, if I jump with my Santa, notice now, the Santa is, bam, just going down. So let me first fix the Santa bending over or turning down. So we are gonna fix that by going into player, and here for the constraints in the rigid body, we need to freeze the rotation on the Z axis. So rigid body, freeze rotation on the Z axis. Now that will make our player, notice if our player now falls down, notice now he will fall down, but he will not go on the side. So the Santa will not go sleepy sleepy. And notice now, when he is on the platform, he is not moving. So he stands on the platform, but it looks like our Santa is wearing his ski shoes, man. So how can we fix this? Well, for that, we need to go in our player script and we need to do a couple of things. So first things first, we need to go back in our script, which is a player script. And on top here below our jump button, I'm going to create private game object, which I'm going to name parent. So this is the parent game object of our player. And now here, we need to create a couple of scripts, or excuse me, a couple of functions. So we are gonna have on collision enter. So here I'm gonna say void on collision enter 2D, which takes collision 2D, which I'm gonna name target. And this is on collision enter. And this will be copy it, and here it's gonna be on collision exit 2D. So what this is gonna do? Well, the collision will be detected. For example, if I run the game now, why am I zooming in? So if I run the game now, as soon as our player touches this platform, it will detect collision between, well, the player and the platform. So as soon as we touch, notice here we have this collider on the player, and notice the first platform also has a collider. As soon as these colliders touch, we will detect collision. Now we have something also called a trigger, which we can, well, set here. If we check this is trigger, but we will do that a little bit later. But if we don't check this is trigger, that means that we can use this on collision enter, which will, well, tell us with which game object we have collided. Now, one thing that I see people making mistakes all of the time is, hey, I wrote this like you did, but it's not working. What's the problem? The collision is not detecting. Well, in most cases, I say, okay, give me the project. And he wrote on collision enter like this. On collision enter with, well, lowercase e. Or on collision enter 2D like this. Well, that is not the case. You can't do that because this function is inherited from mono behavior. If you don't know what inheritance is, go in the basics of C# and take a look at inheritance because it's really important. If we want to have the same functionality as in mono behavior, because mono behavior has this on collision enter 2D function, and it's declared like this. On collision, or on capital O, collision capital C, enter capital E, 2D, capital D. So this is how we also need to write it if we want to take advantage of that function. If we wrote it like this, on collision with lowercase o, it will not work. So in 99% of the times, if you don't detect collision or trigger, because it's the same way as with trigger we write on trigger enter 2D, and if you don't write it like this, and the trigger takes a collider. So here we take a collision, but here we take a collider 2D, which is also a target. I'm gonna name it like that. So we have on collision enter, on trigger enter, on collision exit, and on trigger exit. So the enter or on collision enter will detect when we collide first with the game object. And when that collision is over, then on collision exit will be called. But in 99% of the times, if you don't detect collision or the trigger is not working, well, you misspelled this function. You either wrote something like this, with capital O or lowercase o with lowercase t or something like that, that is your problem. So keep an eye on that. And here I'm also going to say on trigger exit, even though we are not going to use these two at the moment. But now what we are going to do. So moving on to our subject, because I went away a little bit from the subject. So in on collision enter, we are simply going to check if target.gameObject.tag is equal to what? Platform. So if it's equal to platform, this is how we detect if we are colliding with the platform. So here we are colliding with the platform. And if that's the case, then what we are going to say is we are going to say our parent is equal to target.gameObject. And I'm going to copy this code. And when the collision, well, is over, and if the game object that we have previously collided was the platform, then our target or parent is going to be null. Why am I saying this? Well, in a second we will see that. But before this actually works, we need to take our platform, which is this one right here, and we need to go here in the inspector panel where it says tag right here. We are going to click on add tag and click on the plus button, and I'm going to add a platform tag, hit enter. Select the platform and tag it here with the platform tag, because here we are testing if the tag is equal to platform. If that is not the case, then this will not work. So then our parent is equal to the target game object. And now what we are going to do is we are going to go in our update function. So in the update function, for this, we need one more variable. The variable is going to be called has jumped and has touched platform. So if we go here on top, we have under private button, we are going to say private bool, and I'm going to create has jumped. So this will indicate if we have jumped. For the second variable, don't worry at the moment. And we will know if we have jumped, well, when we jump. So here in the jump function, I'm simply going to say has jumped is equal to true. So what we want to do in the update function, well, we want to test if we have jumped. So if has jumped, let's go here, has jumped. So if has jumped and my body dot velocity dot y is equal to 0, meaning we have jumped and our velocity is equal to 0. What that means? Well, we jumped on the platform and then we landed on another platform. So we jumped from the one, for example, we jumped from this platform right here and landed on the top platform. So what we want to do after it? So if we have jumped and the velocity is equal to 0, we jumped from the lower platform, landed on the higher platform, and now our velocity is equal to 0, we are going to say has jumped is equal to false. And we are going to say transform.setParent to our parent. So parent.transform. Transform like this. What this will do, it will set the parent of our game object, which is the player. It will set its parent to be this parent, meaning the platform, which is, well, this one right here. And here I'm going to say else if parent is not equal to null. So if the parent is not equal to null, what we're going to do is we're going to say transform.setParent, and we are going to do the same thing as we did here. So transform.setParent like this. Now, what this will do? Well, let me demonstrate. If I go here, make sure that we don't have any problems, which is okay. Now, notice if I run the game now, if I jump on the platform, notice now what will happen. The player's on the platform and he is moving. And notice where the player is. He's right here. He's right here. Now he has a parent. If I jump again, the player will not have a parent anymore. But notice what is happening. The player is following the platform. The player is following our platform. Notice now, he is not falling down when he jumps. Notice? So notice what is happening here. But he is on the platform. So the player is currently on the platform, landed on it. And notice every time I jump, he's not actually jumping in, well, forward direction upwards, but he's actually following the platform. So this is what we need to fix. But currently our player has landed on the platform and our player is, well, our player is moving with the platform because previously the player was not moving from the platform. Let me just check something here. And on collision, exit to the collision, everything is okay. So yeah. Anyway, if we collide with our platform, then what we are going to do is we are setting here that our parent is equal to the target game object. Otherwise, our parent is equal to null. And we notice that when we jump, then has jump is false. We are setting the parent here. And well, after it, then we move with the platform. Now we do have some issues that we need to fix, such as what you saw. Notice now we are moving with the platform, which is not supposed to happen, but we are gonna check that or fix that in the next video, because this video is, well, so long. More than 20 minutes, I think, or around 20 minutes. But as I said, we did too much, or well, we did much in this video already, and I will see you guys in the next one.